Alright, today I'm going to be talking about E equals mc squared again. I had a Swedish colleague who wanted to be able to visualize the equations a little better. So we'll start off with E equals mc squared, of course. Now, it's important to note first of all that this is at rest mass. So to visualize, basically, first think of a star and think of a star exploding. Now, matter and light go outward in all directions when a star explodes. So it's similar to a volume, except for the energy is equivalent to mass and the speed of light squared when a star explodes. And that's a way to visualize the equations from the standpoint of a star. Now, when a star explodes, it releases light and matter outward in all directions, which is a pure form of energy, E equals mc squared, basically. So this equation and idea opened up the idea for us to use nuclear weapons. So in the real world, of course, it's much more complex than that, but this idea lays the foundation for us to discover how to do that. So that's E equals mc squared from a visual standpoint. Let's see. Besides that, of course, the real theory has a lot more complex consequences and ideas that go along with it, which Einstein already did. So this is just to visualize E equals mc squared. It's a way that even a kid can visualize it. So when a star explodes, it's releasing matter and light outward in all directions. And to convert that into an energy equation, it's mass times the speed of light times the speed of light. Now, moving on to binary relativity, which is the theory I'm working on. It is equivalent to mass times the speed of rotation squared. Now, I already know this is correct and true, basically thinking through the problem. It's basically opposite to E equals mc squared, and basically when a star explodes, its matter and the speed of rotation is the gravitational energy equivalent to visualize it. Now, so let me clarify that the speed of rotation is either the speed of rotation of the object or the speed of spin, and that would be like the average of all rotations. The mean average would give you the speed of rotation or the speed of spin of the object. Now, in the real world, of course, there's things like differential rotation and stuff like that, so gravitational energy could be a little bit more complex in certain scenarios. But basically, it's the surface rotation. So if that's all that's detectable, the mass of the object times the speed of rotation will give you the gravitational energy of the object. So in a nuclear implosion, it would be the mass and the speed of rotation when a star implodes as opposed to explodes. So it's opposite to Einstein's equation, which is why it's called binary relativity. So you can think of gravitational energy as a negative energy and E equals mc squared as a positive energy in some ways. So now this, of course, opens up the idea and the possibility and probability that we can create nuclear implosions, which would be opposite to nuclear explosions, which is, a kind of scary thought and hopefully never needed in the real world. But it's a natural consequence of the theory. But, hopefully we can use it for good things, such as, maybe allowing us to travel at certain speeds using a black hole and kind of science fiction stuff that can be made into reality. But that's a bit of speculation. So this is just to visualize gravitational energy in a simple diagram. So the speed of rotation of the object or the speed of spin, the average, multiplied by the mass, or excuse me, the speed of rotation squared multiplied by the mass is the gravitational energy of the object. Similar to volume, but once again it's a gravitational energy. Now, of course, I already know this is right, but it has to be proven for the scientific community to accept it. But there's, a possibility that it's wrong, of course, always, but the probability that it's wrong is highly unlikely. So anything's possible, but not everything's probable, is what you can take away from that. So anyway, I'm just to let you visualize binary relativity. So let's see if I covered everything. Yeah, it looks like it. So once again, just visualizing a star imploding. The mass times the speed of rotation squared is the gravitational energy equivalent. So let me move on here. Now, fusionary energy is also known as the quantum mechanical relativity. It is the most complex of the three, and they each have, a huge array of consequences and mathematics behind them, which I'm not going to go over for this simple diagram. But now, once again, visualize a star. Fusionary energy is exactly what it sounds like. It's both energies fused together in a star. mc squared plus or minus msr squared, mass times the speed of rotation squared. Now, how this applies to a star is basically the equations add together. The mass times the speed of light squared adds with the mass times the speed of rotation squared in the core of the star. So that's because the gravity can't push it in anymore, and the energies basically combine and create more or less a super energy. So that's the core of the star. Now, around the core of the star there's a zone of probability where both energies are sort of fighting against each other, pushing outward and inward, and that's the zone of probability, plus or minus. Now, around that, the energies are subtractive, so mc squared minus mass times the speed of rotation squared. And that's around the zone of probability. So a star can basically be broken down into three general areas, or volumes, excuse me. The core, the zone of probability, and the outer shell, which is where the energies are subtractive. Now, of course, this is very complex, and there's a huge array of ways these can combine in nature, but this is the best theory to explain that, and a whole lot of other things. So this is just to visualize what I mean by fusionary energy, by the core, the zone of probability, and the outer shell of a star. It's basically a fused energy state where both energies are combined in a star, creating fusion. So, of course, in the real world, for us to make a star, we need the right ingredients and the right conditions, which we can eventually do, but of course there's a lot more research has to be done. But this is the general, to visualize the idea of it. So, I believe I've covered everything. If you have any questions, feel free to leave a comment, and I'll try to answer you as quick as possible. But this is the way to visualize the three equations. I don't have access to PowerPoint or anything like that, so these simple diagrams with a pen in mind is a way for you to visualize the three energies, which is reflected throughout nature. So hopefully I covered it all for you, and I'm leaving the math out so you can just visualize the equations. These are all at rest mass, so there's still math there, but it's basically a simple version, much simpler version. So that will be it. If you have any questions, feel free to leave them, and I'll get back to you as soon as possible. Alright, thank you. And remember, explore your world, explore your universe, explore yourself.